So I wanted to show you all the original prototype that I'd made. I had this case from another project that I ended up using. I drilled 4 holes in the corners, and that was to zip tie it to the frame. But there's the that switch turns the power on and off. The button there is used to cycle through the different light patterns, and then I put an external programming header on it because I got tired of opening and closing the box. And then these 2 leads here go to the light strips, and then this I put on the outside so that I could charge the batteries in there. But let me open it up and I'll show you what I put inside here. Let's see, I gotta turn it over. And this is a 0056 from Pactec, I think. Yeah. And it's waterproof, but it doesn't need to be. So there's the that's one of those cell phone recharging batteries. It's supposed to be a 5,000 milliamp and capable of outputting 3.4 amps. I got it at Micro Center on sale for $17, which these batteries alone cost $10 a piece. So buying this, you actually can save yourself a lot of money if you just need the batteries. Of course, these are solder tab versions, but so I was curious. I wired the power to both of the USB ports to get the maximum amperage, because this port here was labeled capable of 2.4 amps, and this one was labeled capable of 1 amp. And of course, that didn't pan out. I thought maybe the voltage regulator was on the back side of the board. No, that's not true. So it turns out that, oops, let me see if I can, that little dinky chip with the little round circle, that's the voltage regulator. I looked it up. It's like a 7403 or something. And it's only capable of 1.4 amps, which is exactly the amperage that I figured out I could draw from these ports before the thing starts resetting. So I don't know how they could claim that this outputs 3.4 amps when the little teeny voltage regulator they're using is only a 1.4 amp. I have no idea, but I guess it's a marketing gimmick. But there's the Arduino. I just covered it with shrink wrap tubes so that it wouldn't short out on anything. And then I wired everything onto a little board here just for convenience. And there's a large 1000 microfarad capacitor that's on the end where the leads are connected to power, because when you plug these leads in, if they come on you know, full bright or whatever, they actually have an inrush current that's pretty large, and it can burn up the first few leads in your strip. So you want to put a large capacitor to dampen that down. But that was my first prototype. It works okay. It's a little heavy. I've been working on something else, but that's what it looked like. So I got the Adafruit Itsy Bitsy in yesterday, and it comes in just a little package like this. It's the Itsy Bitsy 32U4. It's basically a Leonardo on a tiny board with a USB programming header on it already. It's quite small. It's actually a little bit smaller than the Pro Mini. And then I ended up having to buy these. If I can focus, they're 7414s, they're Schmidt triggers. I had to use that to debounce the button presses. So I added a second button for more options, and then I needed to debounce the button and hardware because I want to do a long press. So you can do a press like this, or you can press and hold for 2 seconds to do something else, and same on this button. And I couldn't get the interrupts to do it properly in software, because I'd have to debounce in the software, and that just wasn't working out. So these Schmidt triggers are like $2 a piece. If you get them on eBay, you can get them even a lot less than that. And that cleans up the signal. So you just use an RC circuit here, and this will translate all the little ringing noise into just a straight up, on, off. And then I'm waiting on today. I'm getting some more potentiometers for the actual product, and they're smaller and they have a knob on the top, and I'm gonna have 2 potentiometers in the final product. I'm gonna use one for adjusting brightness and another one for color or speed. I'm not sure yet, and I might use that button there to toggle what these potentiometers do, but we'll see. I want to give this as many options as possible. The battery, finally got it in from Hobby King. It's the Tenergy or Turnigy, whatever you want to call it. It's a 2S 7.4 volt. You could use a bigger one, but I wouldn't recommend it, because the higher voltage going through a voltage regulator, it has to dissipate that voltage, and it usually gives it off as heat. And so if you get a higher voltage battery, you're just going to generate more heat for no reason. So, and plus the 2S batteries are a lot thinner. They're like half the thickness of like a 3S. So this battery is only 15 millimeters, but it's still 4,000 milliamp. And 4,000 milliamp hour, you know, even if the LED strips were pulling 2 amps, which this battery is definitely capable of, because it's a 30 to 40 C, this battery would last at least 2 hours at full bright, at almost, you know, what would almost look like full brightness, especially like on the American flag. It's just got standard connectors. So I bought 2 of them. There's the one I'm using. I charge it. I've actually been using it for a couple hours now. And then I have this. This was for my quadcopter or drone. You can plug it in line with the battery, and it'll tell you the amperage and the amp hours and the watts and how many volts the battery's kicking out. And then there's the voltage regulator. I bought 2 of them. Let me see if I can find the other one. I may have already pitched it. So I accidentally wired these backwards yesterday on the first one, plugged it into the battery, and the thing exploded on the back side. I'm surprised that they didn't have some sort of bypass circuit, so if you accidentally wire it backwards, it won't burn up. But they didn't, so I burned one up. And it outputs, this one does, it says 5 volts, but it was like 5.19, almost 5.2 volts for the 2S battery. And it'll change based on how many cells you're using. And like I said, you could use, I think this one, this actual voltage regulator will go up to a 12S battery. I highly don't recommend that you use something, if you at all, use a 2. A 2 would be much more preferable, because then this thing isn't like burning off a lot of heat. But so that's going to be in the final product. So it'll be that battery, that voltage regulator, which was only $15 on Hobby King. And one thing about Hobby King is their default shipping method is FedEx ground home delivery. And I discovered that home delivery does not deliver on Mondays. So I was like, why is my product not here? It was supposed to be here a couple days ago. And I called them up, and they're like, oh, you know, we don't work on the weekends and we don't work on Monday. I'm like, well, that's stupid, but oh well. So now I know if I order stuff from Hobby King again, I'm not going to go with home delivery. I'll pay the extra few dollars to have it delivered some other method, preferably like the post office or something, because they're actually pretty good. Anyways, all right, I got a couple other things I'm going to show you in the shop that I discovered, and see you over there. Okay, into the shop we go. Let's turn the light on. All right. So yesterday I was actually it was a couple days ago now, I was showing you how to cut the ends of that. Well, I discovered that sawing it there and then picking it off that way was actually kind of hard. The silicone will actually release from the backing there. Let me see if I can zoom in on it. You can see it. Come on, focus. There it goes. So that right there, if you get under it, will easily peel away. And so what I ended up doing was you peel away just enough like that and then snip it with your knife. Much easier. And it went much quicker too. So that's what I wanted to tell you about in here. Let's move on. Oh, there's my burnt up regulator. So it like, sorry, up in the top right corner, all that stuff melted away. Maybe I can salvage it, I don't know, we'll see. All right, for a little update here. It's been a couple days. I had to order some parts off of Amazon and eBay, and they still haven't arrived. I got some of them, but not all of them. But so I ended up having to change the circuit and the actual board that I'm using. I had to go back to the Arduino Pro Mini. I had to give up on both the Leonardo and the Adafruit boards because the USB code is built in to the bootloader because there is no USB chip on it, so it's handled actually by the MCU itself, and that was causing me lots of grief because one, it shortens your program memory space, and also it eats up some of the CPU time, which was causing me some problems, and I just didn't want to deal with it. So I went back to the Pro Mini. There is no USB chip. You have to plug in an external FTDI board to program it, which is fine. So since then, I have added a power indicator. My two switches, the green one is the main menu, and then the red one is for sub-menu clicks. So once you're in a particular light pattern, you can click the red button to go through multiple light patterns if there's one in that group. The button, I ended up having to use a Schmidt trigger and debounce the buttons in hardware because the signal coming in was just so dirty, and I wanted to be able to do both a click and a long click. So like you can look at the green button there. If I hold the red button down for 2 seconds, then I can actually detect that now. In software, when the button's not debounced, it's like super difficult, especially on an Arduino, because you don't have very much computing power. So it was much easier to buy a Schmidt trigger, which is like $2 for a chip, and debounce it on the board. That way the signal coming into the processor is either on or off. There's no in-betweens. So the potentiometers I'm using, this one is to set the speed, this one is to set the brightness of the leads, and this one is to set the color. And of course these function depending on what pattern you're displaying. These were 10K, and they were really jittery, meaning that whenever the CPU was reading values from here, they were jumping all over the place, and I couldn't get them stabilized, so I went into the datasheet on the Atmel website, which is now Microchip, and it turns out the input impedance on the ADCs, it wants anywhere between 1 and 10K, and I had 10K pots on there, and I hooked it up to my scope and looked at it, and it turns out that anything below 6K was stable, and then any readings above 4K, the ADC had trouble actually locking in on them. So I ordered some 5K pots, which haven't come in yet. So instead I just added a 10K resistor between the two rails to make it a 5K pot instead. And that actually works. So that's okay. The other thing I added was a little piezo buzzer there, just so that I can make a sound when the buttons click. It was just more for me testing it, so I knew I was clicking stuff. And then over here, we've got a barometric pressure sensor, and a little 3-volt regulator, because that one needs 3 volts. And then there's 330 ohm resistors to drop the 5 volts down so it doesn't burn this chip up. But so some of my patterns actually deal with the altitude that you're at, which is kind of cool. And I have more patterns coming for that. So this is how the system works. Right now we're on flags, and flags are the first button. If I hold down this button, that resets it back to 0, which is lights off. And then if I click it again, it goes to the first pattern, which is the US flag. Kind of cool. And then if I come back here, the sub button here makes choices within the menu. And so I've got a bunch of different flags. There's a flag. It's actually the British flag. There's the Canadian flag. The 2 red dots at the top and bottom there are where the maple leaf touches. And then we all know this one, that's the Mexican flag. And then this one is actually blue, white, and red, which I believe is the French flag. And then this one is blue, and there's white up there and red down here, which is the Czech flag. And it just cycles back through. If you're on one, like say the Canadian, and you want to get back to the first, all the functions let you push and hold for 2 seconds, and then reset it back to the first one. And then we can go to the next pattern. And this is solid colors. So right now it's on blue, but if you can see here, this is the color knob. So if I turn that, let's watch. Go through the colors. And then I can set the brightness with the other knob. I can turn it way down, or I can actually crank it way up. And then that was that knob, and so this was brightness and this is color. And then the solid colors, when you're using the knob, you can't get a solid red, green, or blue, or even a white. So if you click through the sub menu, you can get the solid red, which just turns on the red LEDs, and the green, and the blue, and the white. And then you can cycle back to the beginning. The nice thing about this is that once you've made a selection on the dials here, and you change from one pattern to the next, the MCU actually saves all those settings so that when you come back to it the next time, it displays that until you actually touch one of the knobs. So like if we go back to the flags, I'll show you. See how fast the lights are, the stars are flashing. If I speed that up really fast, and I move off that pattern and go someplace else, then I'll come over here and I'll readjust the speed knob. And you can see here the values. So I'll change it. So now it's not where it was before, it's actually much slower. If I go back to the flag, see it's still going fast because it's actually read that out of EEPROM. So it saves all your knob settings for you when you move off the pattern, And then when you come back, it restores them, and it doesn't update it until you actually change the knob value again. So if I touch the speed knob, which I'll do here, see how it jumped to slow real quick, because that's where I had it. And now I can speed it back up. Make it so fast that you can't even see it. But if we go through the patterns here, that's a rainbow fade. Now I can adjust the speed at which it fades back and forth. If I go to the next pattern, these are different strobe patterns. That's 3 flashes every second. It's a standard collision pattern. That's 2 flashes every second. And then this is one I came up with. It's it's like you have the wingtip lights, red and green, and then a strobe flash at both the top and the bottom. And you go to the next one here. This is my police lights. So we can slow it down a little bit. So it does like a double or a triple flash of red and blue, red and blue, red and blue. And there's another pattern in here that rotates between red and blue. And you can speed this up or slow it down. Speed it up. Slow it down. And these are theater lights, chasing lights, which you can adjust the color on. And the speed as well on these. And the brightness. And this one's cool. So I also wrote the algorithm to display Morse code. And since I can't really read Morse code, there's a little indicator light in the bottom corner. It's red, if you don't know if you can see that. Yeah, there it is. So that indicates it's the first Morse pattern, which this one I memorized from back when I was a kid. It's the SOS pattern. It's dee-dee-dee, da-da-da, dee-dee-dee. And then the next pattern, if you look, when it switches, it's got 2 red leads to let you know that it's on the second Morse pattern. And you can put whatever you want here. I think I put the word flat top or something in here. I can't remember now. And then these are like dancing lights. I gotta change some more. And this one uses the altimeter, but I hooked up the color one to simulate altitude. So when it's, let's see here. It's blue when you're at like 50 or 60 feet. It flashes red when you're above the 60-foot mark. And then once you're in the 150 feet plus, it's green. And the lights flash at the top to indicate whether you're going up or going down. And then once you clear like 300 feet, it flashes yellow. It says, hey, you're too high, it's not fun up there. What are you doing up there? Everybody looks like ants. Get back to the ground. But that works off the altimeter. You can do some cool things. I haven't figured out what I'm going to do with that yet. And then it cycles back around to the flag. So my next step now is to make the box that holds all this stuff and the battery. Oh, and I've got to solder a wire coming off of the positive terminal here and goes right into right here to the voltage divider, because I need to keep track of the voltage on the battery, because once it's below like 7 volts, I need to shut the system off, because
once that battery, there's no protection on it, and on a LiPo battery, if you let it drop below like 6.6 volts or something, it no longer charges, and I guess it's a real big problem. So, and you don't want to do that. Those batteries are not cheap. But that's everything right there. So our next step that I'm going to do will be filming, making the case for it and mounting it to the actual flat top. And I'll do that next and post it. And I won't be able to get to that for a couple days because I got some stuff to do today, and tomorrow I'm going to go flying all day. So Monday is when I'll get back to it. But if anybody has any questions, just post them in the comments. I'd be more than happy to answer them or send you some of the source code. I haven't posted it on GitHub yet, but I will be posting it pretty soon under my account, and I'll put a link to it. I've just been very busy, so I haven't had a chance to document and put all that stuff in there yet. But so next time you see me, we'll be building the aluminum enclosure for this and setting it up to get it on the Paramotor. So thanks for watching. See you in a little while.